Hello, I'm Professor Dipak Bhoge. Welcome you all in my e-concept channel. In this video, we are going to see heat pump definition, working and its performance analysis. Now first we will define what is meant by heat pump or definition. Heat pump is defined as the process of achieving and maintaining a temperature above that of the surroundings. Now heat pump is shown by block diagram. Here you can see this is the block diagram of heat pump, in which T2 is the atmospheric temperature and T1 is the temperature to be maintained above the atmospheric temperature. So T1 is our requirement, and here the amount of heat added into the room or closed space, that heat is called as a Q1. So Q1 is the amount that we call it as the output of the heat pump. Now what is the input to the heat pump? Input to the heat pump is the W, which is a Q1 minus Q2. So Q1, from this equation we can write Q1 is equal to W plus Q2. So in a heat pump, from the atmosphere heat is taken and that will be transferred to the room. These heat pumps are used in the cold countries where temperature is far below 10 or 20 degrees Celsius, and room temperature or even in the atmospheric temperature will be in the range of less than 0 degrees Celsius, minus 50, minus 20 degrees Celsius. In that case, heat pumps are used for heating the room. So in such situations, the heat is taken from the atmosphere and that will be transferred to the room. Here Q2 amount of heat is absorbed from the atmosphere and that will be transferred to the room. So, and while doing so, to transfer heat from low temperature to high temperature, we need some work, external work, so that we call it as a W. So from this block diagram, we will get W is the input to the heat pump and Q1 is the output. Now how the heat pump works? Heat pump works on the reverse Carnot cycle, similar to the refrigerator. Now if you see the processes of the heat pump, these are the four processes of the heat pump. 1 to 2 is the isentropic expansion in a throttle valve. 2 to 3 is the isothermal heat addition in the evaporator. 3 to 4 is the isentropic compression in the compressor, and 4 to 1 is the isothermal heat rejection in the condenser. So basic difference between the refrigerator and the heat pump is the requirement. So in a heat pump, higher temperature is the requirement, and in the refrigerator, low temperature is the requirement. Now in these four parts, we are getting the high temperature in the condenser and low temperature in the evaporator. Now here the condenser output is the important in the heat pump, and that will be the output, and input given to the compressor, that W is the input. Again in heat pump there are high pressure lines and low pressure lines. The red colored one are the high pressure lines, that is condenser lines, and evaporator are the low pressure lines. Now you can see 1 to 2 is the expansion in a throttle valve where temperature and pressure will be reduced. In the evaporator, heat is absorbed from the atmosphere and that will be transferred through compressor to the condenser. In the compressor, the pressure and temperature of the refrigerant is increased, and in the condenser, the heat from the refrigerant is given to the room. So this is how heat pump works. Now the performance of a heat pump. Now just we have seen the output of the heat pump is a Q1 and input is a W. So COP of a heat pump is a Q1 divided by W. So which can be written as we know that from the first law, W is equal to Q1 minus Q2. So in place of W you can write Q1 minus Q2. So from Kelvin scale we can write Q1 upon Q1 minus Q2 is a T1 upon T1 minus T2. So finally I am getting COP of a heat pump is a T1 upon T1 minus T2. So here there is one small work. What is the relations between COP of a refrigerator and COP of a heat pump? So one question will be there. The COP of a refrigerator working as a heat pump is given by. So we can prove that COP of a heat pump is equal to COP of a refrigerator plus 1. So in this case option B is correct, and you need to remember, because in many competitive exam, these questions were asked and will be asked. COP of a heat pump is COP of a refrigerator plus 1. So these are the references used.